on. Just copy this down what we're doing here. All right, so first, remember we got to get good at the directions. Step one is look at the directions. So what are you being asked to do? Okay, solve, which means you're trying to find x-intercepts. Okay, so that if you graphed it, you would be able to see, okay, the two places it crosses the x-axis are here and here. So you're looking for two numbers. And usually you write them in x equals, something like this. You got one answer, comma, another answer in these braces. So you have to know from the very beginning what the directions are asking, so you do that. Because I see some people, they really just want to start off with, okay, A is 1, B is this, C is this, and let's find the discriminant, because that's what we've been doing lately. But we're trying to make sure we maintain all our skills. So keep that in mind. Also keep in mind that almost everything we do, you want your starting point to be equal to 0. Okay, you want to be equal to 0. So on these, you'll notice they're not equal to 0. So your first thing is actually to look at the directions, and then look at your equation, see if it's set up to start working on, or do we have to move things around? So like on this one, it's not equal to 0, so I'm going to move that positive 5a by subtracting it to both sides. And this is really my b. I can tell because it has a single variable in front of it. So when you do add and subtract, make sure you add and subtract it to the proper place. So I have my a squared here. This is a. Okay, my minus 24, which is c, but the minus 5a, that goes in the middle. So the location where you put it when you're subtracting does make a difference. Okay, and now it's equal to 0 because 5a minus 5a equals 0. Okay, so I have a little bit of setup. We saw this last week too. Alright, so factoring. Factoring, you should be thinking of the x and the box. Okay, those are the two things that factoring use. So, got to be equal to 0, got to use the x, got to use the box. Our answer looks like this, and our answer graphically means where's across. That's what we're trying to do. So all that you want to have a clear picture of before you even start, and then you can go ahead and do the work. Yeah, what two numbers multiply to a times c? So remember, it's these two. And then adds to negative 5, and you can find your two numbers, which are, let's see, 8 and 3, with a negative on the 8 to get a negative 5 when you add. And then a lot of people use the box for the factoring. You don't have to use it. Just remember one way or another how it works. So we have 1, 2, and we have 4 boxes, but we only have 3 terms. Okay. So to fill in the third and fourth box, that's why we did the x, and we got these two numbers. So that's what goes here and here. So we have 1, 2, and then 3 and 4 come from the x. Okay, so we have first term and last term always the same, but the x gives us the two middle terms. So we got minus 8a and plus 3a. That allows us to get our two factors. All right, go through and find what's the GCF, what goes into both of them. Like they both have an a in common, so I can take out an a. All right, and the row and column should multiply to what's inside, so a times a equals a squared. A times what is negative 8a, you get negative 8. Right? Negative 8 times what is negative 24, and you get positive 3, which is also the GCF of 3 and 24. So there our two factors are a plus 3 and a minus 8. And then you can solve and get our two x-intercepts. Okay. Subtract 3 on both sides. So a equals negative 3. Add 8 to both sides, so a equals 8. Okay. Very end, write your answer like this. Order doesn't really matter, but I usually write them least to greatest. Okay. So that's a factoring to get the x-intercepts. Take a look at number 2 or 3. Now notice how this does not have an A, B, and C, right? There's only 2 terms, so we got to remember, okay, it's not always the same exact steps. We might have to do something different. But with here, it's actually a little easier. It's already equal to 0. Don't worry about that. All we had to do is basically kind of start over here. Act as if like we had 2r squared minus r, and it was in its own little box. Just 2 terms. Right? We could take out an r, because they both have an r common, and we have 2r minus 1 left over. And that's it. There's only one row. There's only 2 terms, so we don't have 4 terms like we did up here. It's really fast. So this multiplies to r times 2r minus 1. Right? And we can go ahead and just solve this right away. Right? There's nothing else we need to do. One of them equals 0, and then the other one will be 2r minus 1 equals 0, which is a fraction. That's okay. It's a 2-stepper. So we got 2 times what equals positive 1. And when you divide both sides by 2, you get a half. 2 times a half equals 1. Right? And then once again, we can write our answers as intercepts. So we get 0 and 1/2. And you'll notice every time there's been a c equals 0, because there's no c on the end of here, right? So it's like a equals 2, b equals -1, and c equals 0. Whenever you have c equals 0, right, it also means one of your x-intercepts equals 0. If you look at it on a graph, in order to have a y-intercept of 0, right, it has to go through the origin. That's where 0 is on the y-axis. But that also makes it on the x-axis, so you always end up with an x-intercept that's 0 as well. So in short, a y-intercept of 0 is also an x-intercept of 0 because it's at the origin. Alright. So that would be a half. This would be 0. I know it's opening upward, right, because it's positive here. So the graph would look something like this. Okay. The vertex would actually be in the middle at a fourth, comma something. You know, that's the middle of 0 and a half is a fourth. So it's the same thing we've done before. Just keep in mind when you get in these answers what they actually mean graphically. Okay? It's on the graph where they cross the x-axis. Okay. And one more. Look at, once again, not equal to 0. So let's put them in the right order. Let's subtract 20 to both sides and subtract 55x to both sides. Conversely, you could have just subtracted 15x squared to both sides. That would get equal to 0. But then I like to keep the a positive. It makes it easier to factor. So subtract it from both sides, and remember, subtract them in the right order. So the one with a variable, that should be my b, that's second. So make sure you put the minus 55x next, and then the minus 20 on the end. That's c, and that equals 0. So the order does matter. You don't want to do minus 20 and then minus 55x. You want a, b, c alphabetical order. Now, with these big numbers, if you just try doing this and saying, what 2 numbers multiply to 15 times 20, which is 300, and add to 55, you'll find it to be rather cumbersome. The numbers do exist, but it'll take a while. So you should probably take a step back before you start that venture and say, can I take out a GCF first and make the number smaller? So looking at 15, 55, and 20, is there a number that would come out of all 3 of those? 5. And we did this when we were completing the square as well. It's just a general strategy. If the numbers are really big, see if you can factor a number out, and now it'll make it a lot smaller. So we have 3x squared, right, minus 11x, and minus 4. Okay, now those are a lot easier to work with. Instead of 300, I'm trying to figure out what multiplies to negative 12, right, and then adds to negative 11. much easier to figure out and faster to solve than 300 and negative 55. Alright? Alright, so we go through here. What are the two numbers? Multiply and negative 12, and they add to 11. Okay. And we get 12 and 1. Yeah. And which one's a negative? 12. Okay. Now, how come we cannot do this? How come this does not work? You see some people do it. What's an easy way to prove, like, well, that's wrong right away, and I can tell pretty easily? Yeah, if you check them, is x times x equal to 3x squared? No. Is 12 times 1 equal to negative 4? No. Right? So you can't just take these two numbers and just put them x plus and x minus, and okay, that's easy. So some of you have a habit of skipping this right here, and that's what causes that problem. If you do this box, even if like you really don't need it here, because the same numbers you get, negative 8 and 3, are the same thing you get here, negative 8 and 3, that's not always the case. So if you skip this and assume it's always like, that's just made up, we don't really need that, that's where things go wrong. So actually go through the work, right, and let's show it, and you'll see why that is the case. So we got, set that back up. All right, do the actual box. So we're doing the small numbers, that's why we took out that 5. So we have these two, and these two, and these have an A on them, right? And those are what go in the box, those 4 terms. And spend the extra 20 seconds and just show the work, right? And do it right the first time, so you're not stopping and looking at it and saying, that's not right, that can't be. Right? So we get negative 12a, and we get positive 1a. And now when we do the GCF, what goes into 3 and 12? You get 3. Actually, that should be in, it should all be x's. I don't know why I switched to a's. Okay, that's from the last problem. Those are all x's. So we also have an x in both of them. Right? So we're already starting off with, okay, this is 3x, not x and x, but one of them is 3x, so we got to multiply to 3x squared. And then 3x times what is 3x squared? We get x. So I know the other one starts with x. 3x times what is negative 12x? We'll get minus 4. So I know this is minus 4. And negative 4 times what is negative 4? And that's just plus 1. Okay. So yeah, we didn't get x minus 12 and x plus 1. We got 3x plus 1 and x minus 4. Alright, so now solve. Remember, if two things multiply and equal 0, that means either one or both of these equal 0. So that's why we set each one equal to 0. And you notice how I leave off the GCF? You don't have to multiply it back in. You end up with the same answer if you do, so that's why you don't have to. Okay, so I get x is negative 1/3. That's one answer. 1/3. And then up here, I get positive 4. Okay. All right, go ahead and do 2, 4, and 6, using these as examples. And really try to do it on your own, and then check with somebody if you get stuck or you get confused, and fix it as you go, okay? And I'll be walking around as well. For number 7, you have to start off just like we do when you're doing the factoring. If you can take out a number, you want to take that out. So you take out, like here, 2. Start it this way. Alright, but here's where it changes a little bit. And you take half of b which is negative 4, right? So after that's going to be 2. And 2 squared is 4, and to get to 3, we just subtract 1. Alright, so I came up with 1 because it's 4. 2 squared is 4, and 4 minus 1 equals 3. Keep it all equal. And then distribute to both. So I can see my vertex is at 2, negative 2. That's where my vertex is. Down here. And on this particular one, I can also graph my y-intercept, which is C, right? So I know that's over here. And because I get this one, I also get this one on this side. And if we wanted to, we could, just to be accurate, right, we can go one below and one above, and we know these have the same answer, and that will give us, well, what should the coordinate be for 1 and 3. So I'll just plug in 1 into my equation, either the vertex form or the standard. So you could plug it into here, or you could plug it into the original one. You'll get the same number because they're equal. So you got 2 times 1 minus 2, so that's just 0, right? So these are actually the x-intercepts. And there we go. And we can finish the graph. So which means if we went through and did factoring, and we factored this, we get an answer of 1 and 3. So it probably factor to, my guess is, if we factored this, it would be x minus 1 times x minus 3. Right? And that would give us 1 and 3 as our answers. So you can kind of tell that from the graph. But not that we had to factor, but just know that everything we're doing is all linked and related. Alright, so you want to get this down and also do number 8, do one on your own. Again, we're trying to build on a lot of stuff, so we got to make sure we're pretty proficient before we move on. And then we'll start the back. If you're already done, go ahead and start factoring everything on the back. So for your homework, we're going to do some, basically it's going to be a lot of review. So step 1, as you can see, it says solve each by completing the square. That's the same as vertex form. And then also factoring. So you're really doing 2 steps for each. Alright, so let's do the completing the square first. And this is all review. So we have this part. So half of 4 is 2. Right? 2 squared is 4. And to get from 4 to negative 21, you have to subtract 25. 4 minus 25 gives you the negative 21. So that's the first part, getting the vertex form. So remember, when you see complete the square, think of vertex form. Okay, just like we did on 7 and 8. Okay, but we're also going to do factoring. So we're going to go through and figure out separately, like a separate problem altogether, what multiplies to 1 times negative 21 and adds a negative 4, and do all those steps as well. Okay, so we'll get 7 and 3. So we have my first, my last, and my 2 middle. For the box, so we have x squared minus 7x plus 3x and minus 21. And once again, please take the time to make this and do this. Don't skip it and say we don't need it, and this is what will cause you a lot of problems later on. Just take the extra 20 seconds, write it out. So we have it factoring to x plus 3 and x minus 7. Got the x there. x minus 7, and this equals 0, and we can get our two intercepts. So on each of these on the back, you're going to have to factor it and get the two answers. So more practice factor. Okay. Oops. There we go. So now what I'm about to show you is how do you get these two answers here, -3 and 7, from this, from the left-hand side. So it does say to solve completing the square. Usually we've just been making it vertex form and stopping, but we can actually get the same two numbers. Okay, so you're actually solving these both two ways, and at the very end it says verify that you get the same answer. So of course if you solve a problem two different ways, it's the same problem, you should get the same answer. So let's show you how to solve this and get these two numbers. So first thing we're going to do is go ahead and add 25 to both sides. So we take that y coordinate of the vertex, right? I'm going to move it to the other side. So I have something squared equals positive 25. Okay. Now, just like when you add, subtract to both sides, multiply, divide to both sides, as long as you do the same thing on both sides, it's okay. It's mathematically sound. So we can do the same thing here. Since we have to the second power, we saw before with our exponents that you can undo this by taking a square root. So we can actually, just like anything else, take the square root of both sides to solve. Okay? And that's gonna be the new part right here. This part in red is really what we're doing that's kind of different. Okay, so we're taking the square root of both sides. Now, before we get too far, ask yourself, we have some number squared and it's equal to 25. What number squared equals 25? So what number times itself equals 25? Okay, you get 5, but what's the other number that does that? What other number times itself equals 25? Think about it for a second. We have 5. What's the other one? There's one more number. What times itself is 25? What is it? -5. There you go. Yeah, -5 times -5 is also 25. So there's two answers. This is very similar to back here where we had like absolute value of x minus 3, and that equaled like 5, and we said, oh, x minus 3 equals -5, x minus 3 equals +5. There are two answers here, right? We already know there's two answers, right? So we better get two answers here. So we know x minus 2 can equal -5, but also x minus 2 can equal +5. There's two numbers that do that work, that multiply to +25. One's -5, one's +5. So that's how we get our two answers. We add 2 to both sides here, and -5 plus 2 equals -3, so that matches. And then when you add 2 on the other one, right, that also matches. So you know you've done it correctly all the way through when you get the same answer using either method. They should never be different. The whole idea is that these two should be exactly the same every time. Same problem, two different methods, same answer always. So to review, when you take the square root of both sides, you get a positive and a negative answer, very similar to absolute value when we were doing absolute value, and they were just v's, right? So we had an answer here and an answer here. So we always had one that was negative and one that was positive, right? Same idea here. You have one that's negative, one that's positive, because there's two numbers that multiply to 25. -5 times -5 and +5 times +5. Okay. go down to like 13. And just recall, just like on number 5, 5 and 6 on the front, if you can take out a number, that's the first thing you want to do. Make your lives easier. Take out a number on both sides. Right. And then we can complete the square. N minus 1. 1 squared is 1. 1 minus 4 equals 3. And then multiply it back in. We get the squared there. That's minus 20. Right. And that's all review. That's what we did last week. But the new part is where we solve. So instead of stopping and saying the vertex is at 1 and negative 20, we're actually solving and getting the answers. Now, this one has a number in the front. Like you see this 5, that wasn't there before. And you see if you try to take the square root right now, you'll get square root of 20, which is some decimal, which doesn't work. So divide that first. Divide both sides by 5, and now 20 divided by 5 is 4, and then we can take the square root, right? We can take the square root of 4. So the number on the right-hand side is going to be a nice number like 4, 9, 16, 25, 36. If you don't get a number you can take the square root of, then there's something wrong before that step. And now we know that n minus 1 will equal negative 2, and then n minus 1 will also equal positive 2. So one's positive and one's negative. That's how we get both answers. And practice doing, on the last one I did factoring first. This one I completed the square first. And just switch off and make sure you get the same answer both methods no matter what order you go in. So here I have n equals negative 1. Here I have n equals 3. So when I do the factoring, I should get the same exact numbers, negative 1 and 3. Which remember that are x-intercepts. Okay? So that's your homework. It's going to take a little bit of time. Give yourself a time. Okay? But you can do it.